Okay, good morning. Now the next part of the lesson is factorization. We learned about this idea in Math 1C. We want to complete it in this course as well. That's an important part of the lesson. So what do I mean by factorization? Let me start with a very simple motivating example. So if I give you number 6, when I ask you to factorize it, what I mean is to write it as a product. That's it. So factorization in principle means writing an expression or a number as a product. So for example, here, I can write it as 2 times 3. Of course, you can also add 1 to it, but whenever you have a factor of 1, you don't write it down because it doesn't matter. Of course, as I told you, I can write 1 times 2 times 3. I can write 1 times 1 times 1 times 2 times 3, but no one writes those factors. So that is one thing. So when I say factorize, it doesn't mean write something which is true. It means not only it should be true, but the right-hand side should be a product. That's the only thing that you have to be careful. For example, if I write 6 is equal to 5 plus 1, this is also true, but this operation is not multiplication, it's addition. So when I say factorize, I mean this. Even though this is true, this is not factorization. Is that clear? And one thing is that when I say factorize, it means that continue as much as you can. So for example, if I give you factorize 12, you can write 3 times 4. Apparently this is correct because first of all, this is true. Second is that this is a product. But if you stop here, it's not complete. So when I say factorize, it means to write as a product, but complete. Okay, so it means that continue this so that you cannot factorize anymore. So in this case, what should I write? Instead of 4, I can factorize 4 to 2 times 2 again. But if I want to factorize 2, the only way that is to write 2 times 1, which I told you 1 is not necessary, so this is complete. So when I say factorize 12, I mean write it as a product so that it cannot be factorized more. So the answer to this is not this one, this one. This is not technically wrong, but this is not complete. Here, we want to do the same thing for algebraic expressions. We had this before. So for example, I can give you x squared plus 5x. So if I ask you what this is, you will tell me this is a sum. Sum of which terms? X squared and 5x. So this is not a product, this is a sum. When I say factorize it, it means to write the same thing as a product. I don't know how much you remember from Math 1C, so if I ask you to factorize this, do you remember anything?
Yes.
What should we do? Yes?
We take
Yes.
we look both of them have something similar.
In common. Yes. So x is in common. So you can take you will take the maximum thing yet you can pull out. So for example, in this case, if you want to, I don't want you to get used to this way of thinking because it would be a mess if you every time you want to do it. But in principle, x squared has 2 factors. By the way, the name of each of them is a factor. So 3, 2, 2 are factors of 12. 3 and 4 are factors of 12. But 5 and 1 are not called factors. These are called summands. So be careful about the difference between the words we use. So here, if I ask you what are the factors of x squared, because you know that x squared has another name, which is x times x. So if I ask you what are the factors of x squared, you will say that, okay, x squared consists of 2 factors, both of them are equal to x. And then if I ask you what are the factors of 5x, what are they? It is 5, because 5 cannot be factorized more. So 5 is the only factor of itself. If you want, you can say 1, but 1 is not necessary. Okay, and then you have 5 times x. And then you see between these two, this x is in common. So you can pull it out. Okay, so you can write x, and then you write x plus 5. Okay, this is technically the way that you need to think, but I want you to because you know we are prepared ourselves for this lesson. So you need to do something that when you multiply it back, it becomes this. This is the best way to do it. Yes, at least for these simple ones. So is factorization complete here? Yes, because I cannot break this x into more parts as factors. I cannot break this into more parts as factors. Okay, so that factorization is finished because this is a product. So this expression is written as the product of two expressions, 1x and 1x plus 5. If I ask you what are the factors of these expressions, what are they?
5x.
One of them is x, the other one is x plus 5. So it contains, it has two factors. One factor is x, one factor is x plus 5 as a whole. Is that clear? So if I want to, this is, I just review this because I want you to remember what was factorization, but we want to complete it this year, this course. Okay, so for example, what do you think about this? If I have 3x squared plus 15 x to the power of 3. So how can I factorize this? You need to find the common factors between 3 and 15. What is the biggest common factor? Yes?
3x.
What?
3x.
Yes, so between these two, no, 3x is not common. So between numbers first.
Oh.
Between numbers is 3, yes? And here, how many factors of x appear? How many? Hello? 2. And how many factors of x appear here? 3. So the maximum factor in common is not 1, is 2. Yes, so you have to pull x2 out. Yes, so you pull x2 out, and then you need to, there is a sum here, you need to put something here, so that when you multiply this back, it becomes this expression. Okay, so what is the first question mark?
1.
1. What is the second question mark? 5x. Okay, and this is your factorized form. And if I ask you how many factors you see here, you see I have a 3. I have 2 factors of x because that is x squared. And then I have one factor which is called 1 plus 5x. So I have 4 factors of this expression. Yes, is that clear? So in principle, factorization is simple. You need to understand because there is some confusion. Sometimes when I say factorize this, I don't want to teach you how to factorize this. This will be the next lesson. It comes, you have to wait a little bit. But I want you to understand, if I write something like this in front of it, is this true or false? Is it true or false what I have written? This equality, is this equality true or false?
True.
It is true. But is this factorization? No, this I don't know. This is a very common mistake. When I give this in the exam and I ask you factorize it, you don't know how to factorize it yet. I will teach you in the future. But at this moment, you should understand this is not a factorization. Why? Because, for example, if you don't see this, and if you don't see this, and if you don't see this, the structure that you see here is something like this. And if I ask you, is this a sum or a product, what is your answer? Yes? It's a sum. Sum between this and that. Okay, but the first one itself is a product, I agree. But if I ask you, is this expression a sum or a product? You cannot say this is the product. When you say it's a product, you need to tell me product of what with what. Yes, this is not a product. Can you understand that? But if I ask you, is this a sum? You would say yes. And if I ask you the sum between which expressions or which numbers, you would say that the sum between the triangle on the one hand and the square multiplied by the circle on the other hand. So this is a sum, not a product. So this is what I'm saying, even though this equality is true, but if you write this as the answer to factorization, this is wrong. Not because equality is not true, because you are not respecting the meaning of factoring. Yes? Factoring means writing an expression as a product. So, not a factorization. So try to learn that. You have to be aware of this. So you can write it somewhere in your notebook, and then this is a sum, not a product. And if because it is not a product, it cannot be viewed as a factorization. Yes, is that clear? Yes, Ismail? Yes, okay. For example, let me give you some more examples of this type. For example, if I ask you to this is what I'm telling you is just a review from Math 1C. For example, if I ask you to factorize this, so let me write 18 x squared y to the third z minus, let me write 24 x to the power of 3 y to the power of 5 z squared, and then plus 12 x to the power of 2 y z squared, and then t to the power of 5. For example, if I ask you to factorize this, it means that write an expression with two conditions. First of all, it is equal to this with three conditions. That expression should be equal to this expression. The first condition. The second condition is that that expression should be a product. The third condition is that you cannot factorize it more. Okay, so when I say factorize, you have to respect all of them. I will not explicitly mention do this, and that. Okay, and if the expression is complicated, you need to do it step by step. First of all, don't get confused. Then try to find the biggest common factor between numbers. Okay? So if you have, of course, I will not give you very big numbers in the exam, but in principle, if you can find the biggest common factor between 18, 24, and 12 in your head, this is much better. If not, I can tell you what to do. Do you remember? We can factorize 18 by this method. You write 18 and you write the... first of all, before doing that, can you guess that number? 6. 6 is the biggest one, yes? I want you to think about a number so that 18, 24, and 12 are divisible by that number, and that number is the biggest possible one. Okay? So, of course, you know that 18 is divisible by 1, by 2, by 9, by 6. Okay? And 24 is divisible by 1, 2, 4, 6, 3, I don't know, 12, and 8. But the biggest one between these three is what? 6. So I pull 6 out. Let me just do that first. And if you are not able to do it in your head, I will tell you what to do. Of course, it becomes lengthier, but it is better than not doing it at all. So between 18 and 24 and 12, I pull 6 out. This is the maximum number, so that 18, 24, and 12 are divisible by it simultaneously. Okay, that is for numbers. And then here, how many factors of x I see? 2. Here I have 3. Here I have 2. So the maximum number of x's I can pull out is what? 2. So I pull x2 out. And then between the y variables, here is 3, here is 5, here is 1. So the maximum number of y's I can pull out is 1. So I put a y here. There is another letter involved, z squared, and z squared. So what is the maximum? 1z. But there is also another letter, but this letter here, t, only appears in this one, not in this one, not in that one. So there is nothing that I can pull out. Yes? So I just stop. And then I start to write a question mark minus another question mark plus another question mark. Exactly like the boxes we practiced a little bit in the previous lessons. So you need to, if you want, I can put boxes here, like the ones that we solved before. So you need to give me 3 question marks and write them down. If you can do it in your head, do it. Otherwise, you have to divide, yes? Okay, anyway, it's better to just do it in your head. Can you tell me what's the first question mark?
3y.
Yes, it should be 3 because 6 times 3 becomes 18. Is there any x's involved? No, because x2 was pulled out. What about y? 2. I have to have 2y and z, nothing. Yes, so that's it. And then, of course, for if it is in the exam, try
Is it
to.
nothing? Is there 3z? It's 2z.
What?
Is there not 3z on the 18?
I don't understand. So let us
Oh,
multiply.
No, it's 3y. I'm sorry.
So this becomes 18. This becomes x squared. This becomes y cubed, and this becomes c. So that's correct. Yes. Now I go to the next one. What is the next question mark? What is the next? About the numbers. Which number should I put here so that when 6 is multiplied, it becomes it is 4?
X,
Yes. And then x,
4y,
and then y to the 4th,
and z.
and z. Yes. And then I go to the last question mark. So what should I write? 2 because of 12. Z, T5. Yes? If you understand this, this is exactly what we learned in Math 1C. Yes, so this kind of factorization. But there is also a new type of factorization that we learned in this course, and that is because we learned 2 rules. One squaring rule and one conjugate rule. Okay? So that is the important lesson. So, for example, if I give you this to factorize it, this method that we learned now does not work. But one thing is clear. Let us tell you immediately. This method that we learned in Math 1C has the priority over any other method that we are going to learn. So if this is possible to factorize it using the method we learned in Math 1C and I reviewed it here, do that part first. Okay? And then ask yourself, can I continue or not? But first of all, if I give you to factorize this without me teaching you, do you have any idea what to do? Yes?
A plus b to the power 2. In brackets.
Yes. First of all, do you remember we learned this? This is the squaring pattern in the other direction. Yes? So if I ask you, what is the answer to this? Hopefully, you immediately remember this is a plus b to power 2. Yes? But when I was teaching you this lesson, I wrote this on the left and I wrote this on the right. But this is it doesn't matter. This is also, if this is equal to this is also equal to that. But why this is factorization? Because you just told me a true equality. So this was also true, but was not factorization. Why do you think this is? Of course, this is true, but why this is factorization? Factorization means writing as a product. A plus b to the power of 2 is also a product. The product of a plus b by a plus b, which we write it more compactly as a plus b to power 2. So yes, when I ask you to factorize this, this is the answer. I want you to understand, first of all, this equality is true. Second of all, the right-hand side is a product. Why? Because a plus b to power 2 means what? Means a plus b times a plus b, that I have written it in this form. Yes? For example, let me ask you another question. Do you think this is factorized form or not? Is this a factorized form? Yes. Why? Because a plus b to power 2 means a plus b times a plus b, and c plus d to power 3 means c plus d, c plus d, c plus d. So if someone writes this as the answer to a factorization, you cannot accept that because you can say that, okay, this is a product. Yes? So remember, powers are acceptable when I say products. But let me ask you this question. If I give you this in the exam, ask you to factorize it, I might see some of you, hopefully not, but I might see some of you have written this. Yes? Can I give the points to the person who wrote this in the answer to the factorization? Yes or no? No. Is it wrong?
No.
It is true, but it is not factorization. Why this is true? Because when I multiply that, it becomes a squared 2ab and then plus b squared. So this is true, but that is not factorization because it is of this form. It's not a product, it is a sum. Yes, is that clear? Okay. So now let us practice a little bit about this. So here, there is nothing that I can teach you. You need to train your eyes to catch the squaring pattern, and then whenever you catch the squaring pattern, you just write the answer. That's your duty. Yes, exactly. You remember we had some box exercises before. They were preparing you for this reverse engineering part. And that is called factorization. For example, if I give you this in the exam and I ask you to factorize it, what do you think I can do? Again, resistible. There will be no miracles. If you write this is true, but it is not factorization. So cross it over. For this problem, you get 0. Yes? Do you agree? This is x plus 1 to power 2. There is only one way. You have to train your eyes to catch the pattern. So, do you see that? Because let us do it in the other direction. The first one squared, 2 times the first one times the second one, and the second one squared. Yes? Okay. So that's the factorization. And then if I give you, for example, this one, I ask you to factorize this. So what's the answer? Again, you need to see that if there is any squaring rule whose answer is this. Yes? X minus 2 what? To the power of 2. So that is nothing I can teach you. You have to be able to guess. The first one squared, 2 times the first one times the second one with the negative sign, and the second one squared. Yes? So that is also true. But you have to be careful. For example, what do you think will be this one? Usually after solving those two, people make mistake here. I hope that you're not making mistakes. So what's the answer to this one? Yes, it's mine.
2x plus 1.
I just told you people make mistake and you just did that, yes? So you said 2x plus 1 to power 2. Let us check. The first one squared is correct. 2 times the first one times the second one becomes what? What is the answer? 2 times 2x times 1 is?
4x.
But this is 2x. So this is technically wrong because they are not equal. So don't fall into this trap. Sometimes expressions are not factorizable. Okay? So if I give you this in the exam and you just write that, that's a mistake because this equality is totally wrong. Because the correct one is that when it is 4x. Is that understandable? Okay, so in this case, you should say that this is not factorizable. Just stop there, yes? Exactly like, for example, if I insist you to factorize 5, 5 is not factorizable because 5 is a prime number. So some expressions, some algebraic expressions are also not factorizable. So if I give you this in the exam and I ask you to factorize it, if you write this in front, it means that you didn't respect the equality, meaning of equality. So when I give you this in the exam, so you just write not factorizable. Yes? But if I give you this, for example, in the exam, what's the answer? What?
4x plus 1.
No. First of all, don't say 4x plus 1. You have to say power of 2.
2x.
2x? Okay, then? Not plus 1. You have to respect this sign. Minus 1 to the power of 2. Okay? So it is 2x minus 1 to power 2, and I always recommend you, when you wrote this, try to see if this is really true by checking it out. So the first one squared, 2 times the first one times the second one squared. So this is one of those questions that the answer is required. If I gave you this and you wrote something like that, that you just missed the point. And if I give you this, you just write this, you get all the points. So be careful about that. Let us practice a little bit more here. Okay. So, for example, what do you think about this? Let me write a to the power of 4, and then I have 6a to the power of 2 plus 9. So I give you this and I ask you to factorize it. How many terms you see? 3 terms. Okay, 3 terms. How many complete squares you see? 2. One of them is a to the 4th, the other one is 9. A to the 4th is the second power of a squared. 9 is the second power of 3. These observations give some hints to you that might be squaring rule is a good choice for this. But this is not guaranteed. You see, in this case, 4x squared is the second power of 2x. 1 is the second power of 1, and I have 3 terms, but it was not factorizable. Okay, so these are the observations that you can make to convince yourself that this might be the case that the squaring rule will work. Okay, because I have 3 terms, I have 2 complete squares. So what is the rough guess? So you put pair of brackets here, you put a power of 2 here, and then you write your guess here, but before making sure that is correct, you have to check it out. Okay, so what is your guess? What?
A plus
Not a. A to the power of 2 plus 3. And then before making sure that this is correct, double check. Double check means calculate this based on what we learned before. The first one squared becomes what? This one. 2 times the first one times the second one really becomes the middle one. Yes? And then the second one squared becomes this. So that's the answer. Is that right? Understandable or not? But one type of questions are a little bit more delicate. You have to be careful about them. For example, if I give you this, and I ask you to factorize this one. So this is important so far, because if I give 1 point to this, for this question, I will give you 2 points or something like that. So this is an important question, not because it is hard, because I want you to pay attention. Okay, first of all, how many terms you see? 3 terms, but none of them is a complete square. Okay, you need to remind yourself about what I told you before. I told you what you learned in Math 1C for factorization has priority to what we are going to learn. Okay, so if I have given you in Math 1C, the method in Math 1C you use is to do what? What do you write in front? In Math 1C, you are not aware of this rule, but you in principle can factorize it up to some point. What is that? We just learned.
Just put X up.
You put X out, yes. So you put X out, and then how many question marks you need to fill up? So that when you multiply this back, you get this. What is the first question mark?
X squared.
X squared. What is the middle one?
2x.
2x. And what is the last one?
1.
1. In Math 1C, it was okay if you stop here. But in Math 2C, you have to continue, because when I say factorize, it means factorize as much as possible. This is factorization, I agree, because that's a product, but it is not as much as possible yet, because this one itself can now be factorized more. Yes, so I copy and paste this one. What should I write here? X plus 1 to the power of 2. So let us say that this question, I dedicate 2 points for it. In Math 1C, you got 2 points up to here. But in Math 2C, you get 1 point here, 1 point for completing it. Is that clear? So remember, the method that you learned in Math 1C has priority, if possible, to all other methods of factorization we might learn. Yes? Okay, so let us give you another question of this type. For example, let me give you 5b to the 4 and then plus 10b squared and then plus 5. If I ask you to factorize this, so what do you do? So what should I do for this? Yes?
Take out 5.
First take out 5. Yes? Be careful. If you can apply method that you learned in Math 1C, don't think. Do that one first and then think. Okay? So I see 5 in common between these three, so I pull 5 out. What is left for me? You have to write it in 2 steps. Don't do it in 1 step. So 5, it is b to the 4th plus what? You need to write something so that when you multiply this back, it becomes this. What is that? 2b second, and then plus 1. Okay, in Math 2C, that was the end of the story, but if possible, I'm not saying it's always possible, if possible to factorize more, and you don't do that, you will miss some points. Is it possible here to continue? Yes, because now this is a squaring rule. So what's the answer? b to the power 2 plus 1, and then the power. And then always double check. The first one is squared, that's correct. 2 times the first one times the second one, that's correct. The second one is squared, and that's finished. That's the factorization of that. Okay. So what about this one? I will write it like this. So 9a cubed b plus 12a squared b squared, and then plus 4ab cubed. Okay, I want to wait for you, okay? Please start doing it. I write one more here. If you finish, you do this one as well, please. Yeah, if you did the first one, do the second one. Hopefully I haven't made a mistake. Okay. So do you have any suggestions here? So you see immediately that you can factor something out from all the terms, which is Math 1C lesson. So don't think. That has priority. Okay? So can you tell me what can I put maximally? 1a from, yes, because here I have 3 a's, 2 a's, 1 a, so the maximum number of a's I can pull out is 1a. But before a's, I need to consider numbers. Is there something in common between numbers? No, of course 1, it doesn't matter. Okay, so I pull 1a out, and then is there something else?
B.
A b, so I pull a b out. And then what is left? 9a squared plus 12ab plus 4b squared. Okay, in Math 1C, I told you this is the end of the story, but here in Math 2C, you have to be careful. It might be possible. I'm not saying it's always possible. It might be possible that what is coming out is also factorizable. And if you don't do that, then you will lose some points. Is it possible to do something here? If you don't mind, let me write it more clearly here. So from here, AB, and then I have 9a squared plus 12ab, and then plus what? 4b squared. Okay, can I continue? You need to be suspicious here. Why? Because you say to yourself, I have 3 terms, 2 of them are complete squares. It might be an indication that it is possible to factorize it using a square rule. It might be, not necessarily, okay? But is it the case or not? Is it? No, yes? Because, so let us see. It is, by the way. If you missed that one, so you missed. So you see why? Because I put A and B. If this is going to be true, this is equal to what? 3A plus 2B squared. But it is not guaranteed yet until I check it out. The first one squared is really true. 2 times the first one times the second one is how much? What is this? 2 times 3 times 2 is 12. 8 times B is 8B. So that is also true. And the second one squared is this one. So you see, if you don't recognize that, be careful. Don't get used to of writing it immediately, because if it was 6AB, then it was not true. But now that it is 12AB, it is true. There is nothing more I can teach you here. As factorization, you have to be a little bit creative yourself. So this is, if there are 2 points for this question, 1 point you will get up to here, another 1 point you get up to there. Yes, is that clear? Okay, what about the next question? First of all, between numbers. So this is one of those questions that Math 1C becomes more important first. Between numbers, what is the maximum number that I can pull out?
2.
It is a 2, apparently, yes? So from numbers, it is a 2. Okay, from x's, how many x's I can pull out? 1 at most, because here we have 3 x's, 2 x's, but only 1 x. What about y's? Y squared, because I have 2 y's, 2 y's, and 3 y's. So the maximum one is y squared. Okay, so then I have 3 question marks to fill up. Yes? This one, minus, plus. So what are these question marks? The first one is?
25x.
What?
25
25
squared.
x squared. Double check. If you multiply this here, it becomes 50 x cubed y squared. That's correct. What about the second question mark?
30.
30 and then x.
Yes.
That's it, yes? And then the last question mark? What?
9.
9 y. Yes? Okay. Can I factorize this more? No. So in this case, you see that this is not always the case, that when you put something out, it is possible to continue, because that's not the pattern as you see there. Okay, so this one is a simple but tricky. How many of you could find the way to do it? 2x minus x squared minus 1. Here, the trick is, because if I have given you this one, let me ask you a question about this. Could you write an answer for this one? This shouldn't be hard. In your head, you can interchange them, yes? So it becomes x squared plus 2x plus 1. I can give you this in the exam, but it shouldn't be hard for you to understand this one and that one are equal. And what is the answer to this one? X plus 1 to the power of 2. Okay? So be careful. Usually I put them in order, but order is not a necessity. Yes? If I have given you this, you need to interpret that this one and that one are equal, and the answer to this one is this one, so we are done. But there is a little bit of problem here. Okay? So even if I interchange them, I put x squared first, but be careful, x squared has a negative sign. So if I want to interchange them to put them in order, Then I have to write minus x squared because x squared has a minus sign. Then I have to write the middle one. The middle one is without signs. It means it is positive. And then I put minus 1 here. But can I write this what? Can I write something for this?
Yes.
What?
Minus x plus
Minus x plus?
1.
Plus 1 to the power of 2. But that's not correct. Why is not? Because you say the first one squared. The first one is minus x squared. What is the answer to minus x squared? X squared, which is I have a problem. So this is not working. This is a good guess, but it doesn't work. So you need to change your guess or you need to find another way. Yes.
Can you put the minus sign outside the bracket?
So yes, we can do something like that. So in principle, we had this in Math 1C as well. So you need to engineer it in this way. You put the minus sign out. Then what happens to minus x squared? It becomes positive x squared. And then this was already a positive 2x, but I pulled the minus sign out. So to compensate for that, I have to put the minus 2x there. And then this was minus 1, I would write plus 1. Okay, is that right or not? Because I told you that if you want to open up these pair of brackets, this minus sign is going here, there, and there. So if it goes here, it becomes minus x squared. It goes there, it becomes plus 2x. If it goes there, it becomes minus 1. So that's correct. But what was the benefit of doing that? Because now I can continue. I couldn't continue in this form, but if you have, this is a tricky question, not because it is hard, because you have to remember, pull a minus sign out. And then if you pull a minus sign out, I copy and paste the minus sign. Can I write something for this? X minus 1 to the power of 2. Is that right? Yes. The first one squared is really x squared. This is minus, I put a minus. 2 times the first one times the second one is really 2x. And minus 1 to power 2, 1 to power 2 is 1. So that's the answer. This is the factorized form of this one. So sometimes the trick is to put just a minus sign out and the rest of it will work. Yes? Okay. Of course, we will practice about this more, but there is another part of the lesson. I think you would guess. What is the next lesson that I will teach you for factorization here? We reviewed something in Math 1C, and then I started teaching you the new lesson based on which rule? Squaring rule. So what is the natural next step? Conjugate rule. Teaching you how to factorize using the conjugate rule, and that is extremely simple. Okay? If I ask you, can you factorize this? What is your answer? Everyone, yes? Yes?
A minus B, and then another parenthesis is B.
A plus B. So that is also, first of all, is what Ismail said true or false? It is true because we learned this is equal to that. Of course, if this is equal to this one is also equal to this. So this equality is valid. But is this a valid factorization? Yes, because it was a difference, but now you wrote it as a product. Well, that's the meaning of factorization. So whenever you see the difference of two complete squares, this will remind you about what? Factorization using the conjugate rule. But be careful, let me emphasize that this should be a difference. Yes? For example, if I give you a difference of two complete squares. For example, but remember, if you want if I have a squared plus b squared, it is in general not factorizable, okay? So if I want to start with a very simple one, I can give you to factorize this. 4x squared minus 25y squared. If I give you this in the exam to factorize, it is easy to catch the idea. because the pattern is very clear. First of all, you have two terms, and the sign between them is negative, and they are complete squares. So whenever this happens, you remind yourself of the conjugate rule. So you open two pairs of brackets, put a minus sign in one of them and a plus sign in the other one. It doesn't matter in which order you want to do. Let us put the minus sign here and plus sign here. Okay, you need to write something so that the conjugate rule gives you this answer. And that is clear. What should I write here?
4x.
No, not 4x. Something squared becomes 4x squared. So it should be 2x, not 4x. Yes? Because the first one squared becomes, so when I put the 2x here and a 2x there. Yes? And then what is the other one? Something that is squared becomes 25y squared. 5y. So a 5y here and a 5y there. So is that factorization? Yes. Was it factorized? No, it was a difference. Difference is not a factorized, but it is a product, so it's factorized. Yes.
When it's conjugated, you can only use it's a conjugated. Can you only use it when it's minus?
Yes.
As the
Yeah. This is why I wrote you that if it's a plus, it's not factorizable. Okay. Yeah. So remember about this. Okay. Let me give you another example. So, what about this one? X to the power of 4 minus y to the power of 4. Can you factorize this? Yes? First of all, it is a difference. There are two terms involved, and the terms are complete squares. Everything is suitable for a conjugate pattern. So what should I write? I immediately open two pairs of brackets, put a minus sign in one of them, plus sign in the other one, as you like. It doesn't matter. Let me this time put plus there, minus there. And then you ask yourself, what is that expression whose second power is x to the fourth? What is that one?
X squared.
X squared. So you put x squared here and x squared there. And then what about the other one? Y squared. Yes?
Yeah.
But if there are 2 points for this question, if you stop here, you miss 1 point. Why?
You can factorize it.
More. Why? Because this, can I factorize this? No. Plus sign is not factorizable. But this is another conjugate pattern. So you have to continue until you cannot factorize anymore. So how should I continue? I copy and paste the first one, which I know is not factorizable anymore. But I open two pairs of brackets, one with plus sign, one with minus sign, and then I ask myself, how should I write something whose answer is this one? It is simple. What should I write?
X.
X here and there, and then
Y.
Y here and there, and then you stop. So sometimes it is possible to make it more. So let me ask you another question. What about this one? So 4x squared minus 4y squared. The reason that I am telling you because it has some important points. So what do you say here? Is it a conjugate rule or not to factorize?
Yes.
So give me the answer if you want.
Is it 2x, then 2x minus 2y plus 2x plus
2y. Yes. This is correct. It is not. This equality is not wrong, and even factorization is correct, but not complete. Because I told you, Math 1C lesson has priority. Okay. So if I have given you this in Math 1C, how do you do that? 4, and you have to do it because it is not complete. So you have to factorize 4 first. Remember, the method you learned in Math 1C has priority over all other factorization methods. And then, if your stop here is not complete, in Math 1C it was complete, but in Math 2C you know you have to continue. So you put 4 here, and then you factorize this. So that is the correct factorization. Okay, so what you wrote was factorization, was also true, but was not complete. Be careful about that. So remember this from now on. Mat 1C method has priority over all other factorizations or if possible. Yes? Okay, so what about this one? X to the power of 2, y. No, let me write x to power 3. X to power 3 y minus x y to power 3. I ask you to factorize this. So what should I do here?
Factorize xy.
Okay, so again, the Math 1C lesson has priority. Is it possible to do it using Math 1C lesson? Yes, so do it and then think it is complete or not. So what can I factor out?
X, Y.
From these two x's, I can pull at most one x. Between these y's, I can pull one y out. So what is left for me? X to the power of 2 minus y to power 2. In Math 1C lesson, here it was finished, but in Math 2 lesson, you know you can continue. So you continue. What's the answer? xy, x minus y, and x plus y. Okay? Understandable? So factorization using conjugate rule is not complicated because more or less it reveals its pattern. Okay, so let me give you more examples. So I write this one. If I don't know how much you know about the numbers, but I can help you. I will not give you these big numbers in the exam if you are not allowed to use the calculator. But here, let me write it. 121 a to the third x minus 49 ax cubed. So, what is your opinion here? You shouldn't think that much. Don't get confused with numbers. I don't know. Do you know 121 is a complete square? Yes? Do you remember what number is that? 11. 11 to power 2 becomes 121. But I told you, if it is in the exam, I will not give you very big numbers. And 49 is the complete square of which number? 7. But of course, 7 and 11 has nothing in common, so I cannot pull anything out from the numbers point of view. But from the letters point of view, it is possible. And I told you that Math 1C lesson in factorization has priority. So let us assume that, pretend that you are still in Math 1C. So if you want to factorize it, what do?
AX.
You take a and x out. So what is left for you? 121 a squared minus 49 x squared. So in Math 1C, here the answer is complete, but in Math 2C, is it possible to continue? You have to always ask this yourself. Is it possible? Might be in the exam, I give you this, and then I ask you to factorize. Then you don't need calculator. So what do? I copy and paste ax, but do you see that this is the conjugate rule? Because this is the complete square, that's complete square, and that is the minus 9. Do you know what's the meaning of complete square? Something is a complete square if you can find something to power 2 becomes that. That's a complete square. So is there something to power 2 becomes this?
Yes.
Yes, what is that thing? 11a. So yes, that is a complete square. So I open two pairs of brackets, 11a here, 11a there, one with plus, one with minus. And is there something to power 2 becomes 49x squared? Yes, what's that? 7x. That is the way. In Math 1C, you stop here, you collect all the points, but in Math 2C, you have to continue up to here to collect all the points. Yes? Okay. Any questions so far? So we reviewed one factorization method and two methods that we learned today, but we also learned something later when we learned about quadratic polynomials. And that was probably one of the important ones that we will study this year. Okay, there was one question in Math 1C, do you remember? We simplified fractions using factorization. And that was one important part of the lesson, which you will get more complicated questions for this course. Similar questions, but a little bit more complicated. And then, so do you remember what type of question I'm talking? For example, I ask you to simplify this fraction, x squared plus 2x over x. Okay, we want to simplify this fraction. Okay, if you want to simplify a fraction, be careful. The first thing is we can do it algorithmically, like this. You factorize the numerator, you factorize the denominator, and you cancel common factors, not summands. For example, if I write x plus 5 over x, I have seen many students, it doesn't matter how much I repeat it, some people simplify these two x's and then write the answer to be 5. Okay, so that is not correct. For example, let me write 2 plus 5 divided by 2. If I ask you what is the number, if you simplify this and then the answer 5, it is wrong. What is the correct answer?
3.5.
Yes, because 2 plus 5 is 7, 7 divided by 2, and then this becomes 3,5. Okay, when you see in front of your eyes, this is not working, so don't do it. Okay? So why we couldn't simplify this x with that x? Because this x is not a factor of the numerator. What is it? It's a summand. Yes? X is added to 5. So you cannot say x is a factor. Factor is something which is multiplied. But x is added to 5. Yes, I agree with you. X here is the only thing we can consider it a factor. But x is added to 5. So x is a factor for the denominator, but x is a summand for the numerator, even though they are the same things, but one of them is a factor, the other one is a summand. We cannot simplify a summand with a factor. We can simplify factors with factors. Okay? If not, don't do it. Okay, so, for example, can I simplify this x with that x?
No.
This x is a factor of this one, I agree, but this x is not a factor of the whole. So first of all, remember, factorize the numerator, factorize the denominator, if possible, and then simplify common factors. That's it. The algorithm is 3 steps. Factorize the numerator, the denominator, cancel out the common factors. I don't know why people make mistakes so much. So here, can I factorize the denominator?
No.
No. It's just simple to just write it. But can I factorize the numerator?
Yes.
It's a Math 1C lesson. How can I factor it out?
X.
X, and then write what? X plus 2. Okay, now if I ask you how many factors do you see in the numerator?
1.
No, in the numerator 2. One of them is x, the other one is called x plus 2. X is one factor, x plus 2 as a whole is one factor. And then how many factors I have in the denominator? That's just one x. Do you see something in common in this list and this list?
Yes.
Yes, that is the same. I don't want you to write so many things. I want you to understand it. Okay, so what do? You simplify this x. It is possible. I am not allowed to simplify this x with that x. I am allowed to simplify this x with that x because this x is a factor. This x is not a factor. The factor is x plus 2. So when I simplify, what is left? I divide. When I divide, 1 is left. No one writes 1 in the denominator. Yes? We simply multiply 1 by x plus 2, it becomes x plus 2. So the answer to this is x plus 2. This is an E question in Math 1C lesson, okay? But now that we have learned a little bit more about factorization, we can solve a little bit harder problems, yes? So I don't want to actually do that myself. I want to wait for you to do these two problems for me. Let us do this problem together. This is completely Math 1C lesson, and I think, unfortunately, they haven't give you any example which is related to Math 2C. I will give some examples myself, okay? And then after that, the first one is a level 1 problem. This one is a level 2 problem. Okay, I want to wait for you to do these two. So remember, 3 steps. Factorize the numerator, factorize the denominator, you will still collect points. So let us say there are 3 points. You get 1 point for factorizing the numerator correctly. You get another point to factorize the denominator correctly. You get another point if you can simplify correctly. Okay? So just do that. You should be able to do it very fast. I mean, this one is a little bit better, but I can give you much convincing examples now. If you don't mind, let us start because we have only 10 minutes. So that one are very simple, I hope you. So I hope that none of you make a mistake to simplify this a with that a or this a with that a, because they are not still factors. So you follow the rules. Factorize the numerator. Math 1C lesson is here, we factorize. So what's the answer? Yes, what's 4a minus 1 divided by a. Okay? Now, can I factor this a with that a? No. But can I can I simplify this a with that a? No. Can I simplify this a with that a?
Yes.
Yes. So I simplify it. What's left?
4
This is the answer. Okay? The only thing that I see students make mistakes is to simplify wrong ones. So, again, the algorithm. Factorize the numerator. Okay, what can I do? How can I factorize this? Am I recording this? How can I factorize this? I pull 3x out, yes? And then what is left for me is x plus 2. Can I factorize the denominator? No. There's no pattern there. So I have to copy and paste it again. But can I simplify something?
Yes.
Yes. Because this is the only expression in the denominator. How many factors you see in the numerator? One of them is 3, one of them is x, and one of them is called, say, x plus 2. And now you see x plus 2 is a factor. X plus 2 is a factor, so I can simplify this x plus 2 with that x plus 2. Yes, and what is left is just 3x. Understandable? Yes? Okay, a little bit harder questions here. So, again, follow the algorithm. Factorize the numerator. What's the answer? This is still Math 1C lesson. 5 you pull out and x you pull out. What is left here? You need to write the question mark so that when you multiply in, it becomes this. So what's the first one?
3.
3, and the second one? So sorry, 3x. And the second one is? Some, yes, 1. Because you want to multiply and it becomes, that's correct. What can I factorize here?
5.
Only 5. So I factor 5 out. This becomes 5 minus 2x. Yes? Can I simplify something? This 5 is a factor, but this 5 is not a factor. Yes? So this 5 is a factor, what about this 5?
Yes.
It's a factor, so I can cancel them out. So this 5 and that 5 are gone. So what is left is x times 3x plus 1. And what is left here is 5x minus 2x. 5 minus 2x. And I don't need pairs of brackets. You can stop there, but I prefer when something this x can be simplified with that x? Yes or no?
No.
No, don't doubt about it. They cannot be simplified. Yes? If this was like this, yes. But now 2x is one term, 5 is another one, and they are being subtracted. So this is not a factor of the denominator. X is factor only of this part, not the factor of the denominator. If you want, you stop here, but I prefer when nothing can be simplified more, I multiply back and put it in the original form. But this is not mandatory. You can stop here if you don't like it. Okay? What about this one? Again, the algorithm is to factorize the numerator. Between 11 and 33, I can pull 11 out. Between x squared and x squared, I can pull x squared out. What is left? Y squared minus 1.
No, 3.
Sorry, minus 3. Yes. But you see, can I continue more? No, because even though it is two terms, one of them is completely squared, the other one is not completely squared, so that's not the conjugate rule, so you have to stop there. What about the denominator? Between 22 and 55, is there any common number?
Yes.
What is that? 11. Between x squared and x squared, again x squared. What is left from the first one? 2. Yes? What is left from the second one? 5y. So I have 11 x squared, y squared minus 3. One factor, another factor, another factor. One factor, another factor, another factor. So these common factors can be simplified. Yes. Yes, I know. It becomes y squared minus 3 divided by 2 minus 5y. But this y and that y cannot be simplified anymore, and then you have to stop there. Okay, thank you, and be prepared for the test.